Hi everyone, how you doing? Thank you for coming today. I'm Hossein Ahmad. Thank you all for coming. We're really excited to have you. Just so you know, this event's going to be recorded and will be posted on the Rutgers Engineering website afterwards. There'll be a Q&A following Dr. Bhattacharya's presentation today, and all guests will be muted during the event, but any questions can be posted in the chat anytime to be answered during the Q&A session. So getting into the event a little bit, ever since the dawn of the space age, humans have envisioned a future with a sustainable space economy. For decades, the space industry has relied on expensive cost-plus government contracts and has been vulnerable to shifting political priorities. Although in recent years, the commercial space industry has come to disrupt that and is helping to increase access to space for everyone. The commercial space industry is quickly evolving from proof of technology to consumer-driven goods and services. How will this help citizens of planet Earth during our post-COVID recovery? And why is this the right time for you to get involved? We have Dr. Bhattacharya here today to talk about all that stuff. Dr. Bidushi Bhattacharya graduated from Rutgers with her bachelor's in mechanical engineering and physics in 1988 and is an ex-NASA scientist turned entrepreneur with 3 decades of experience in spacecraft development and operations, commercial space startup growth, academic administration, and scientific research. She's the founder and CEO of AstroHub, a Singapore and US-based startup dedicated to space workforce development for professionals and students through interactive online courses and hands-on training using cubesats and International Space Station research. Dr. Bhattacharya believes that her Rutgers education provided key programming and scientific analysis skills that enabled her to land a position as a calibration engineer on the NASA Hubble Space Telescope after graduation. Since then, she's worked on a number of missions, including the Mars rover program, the Galileo mission to Jupiter, and the European Space Agency's Herschel Space Observatory. Her vision is to democratize global access to outer space, and she also plans to take her husband on a space tourism vacation for their 50th wedding anniversary in 20 years. She also has a PhD and MS in space physics from UCLA. So thank you again for coming, Dr. Bhattacharya, and I'll hand it over to you.
All right, thanks. Let me just make sure you can hear me. Thumbs up if you can.
Yep,
okay, awesome. All right, well, thanks everybody for making the choice to join us this afternoon. I know we've all got a lot on our plates and some of us are a bit zoomed out, so I appreciate your time. And I'm hoping that this is an informative and fun experience for you. This is particularly exciting for me because I was an undergrad at Rutgers and I feel like I'm kind of coming back to home base. Our business is all over the world, but this particular talk is really meaningful to me and I hope it ends up being that way for you. So let me just get to my slides here. There we go. Yeah, so the whole point here is to talk about your role in astropreneurship, particularly in the context of the post-COVID-19 planet. We're in a realm now where things are changing very quickly, and what I want to do is give you a sense of where the space sector is right now and where it's going and how you can actually step in, not just to have a really interesting career opportunity, but because I think you can actually help the citizens of planet Earth. So let me start with a poll question. Just think about this for a second. Have you ever dreamt of being an astronaut? Yes, I want to see planet Earth from afar, or no, I prefer to take advantage of the gravity down here on Earth. What I typically find is I get like a 1/3 people wanting to stay on Earth, 2/3 want to be astronauts, but I'm just going to guess that with this particular audience, because we are more of a technical background being associated with Rutgers engineering, that probably most of us have been kind of wanting to be astronauts on some level or another for most of our lives. So the next thing I want to do is just really think about where you guys are in terms of the space sector. So I give you 4 choices here. When I ask how familiar are you with the space sector? Are you astro curious, as in you're new to the sector and just curious about it? Are you astro knowledgeable? Like you have some basic knowledge and you're interested in learning a bit more? Are you an astro nerd, such as myself, where you have direct work experience in the sector and you wanted to find a future, or are you an astronaut? Been there, done that. And depending on the audience, I do get astronauts. So I get one here. I think that'll be really cool. But you just figure out where you lie on the spectrum, because this will give you a sense, of what you want to look out for as we go through the talk. So what are my goals today? My goals are to talk to you about the rapidly growing commercial space sector, which is called new space, and to learn about the unique vantage point and benefits of being in outer space, and to figure out the fact that there are technical and non-technical opportunities in new space. This is important, technical and non-technical. And I also want to take away the mystery of rocket science, because I really do see rocket science as being perceived as hard is really a barrier to entry for a lot of people. A lot of very capable people out there who could actually contribute significantly to the field, but they just think, oh, it's rocket science, must be hard. So they don't participate. And I'm hoping that we take some of that away by the end of this if I do my job properly. And finally, I really want you to think about and understand why new space needs you. So let me start off by defining something that I call big space. So this is, of course, where I started my career working on the Hubble. These were projects that were billions of dollars, billion with a B. And these are big NASA projects, and they're super critical, super important, because they paved the way for all of us to get to where we want to be today in terms of technology. Without NASA, without big governments in Europe, and in Asia, all over the world, we would not be where we are today. So these were essential back in the old days. The Hubble Space Telescope was a $4 billion project. And I also worked on the Galileo spacecraft for my PhD from some other state school. And that was also a multi-billion-dollar project. It went to my favorite planet, Jupiter, so that was a pretty cool experience. All right, so just because this is Rutgers, I'll tell you a little bit more about myself. I have a bachelor's in mechanical engineering and a BA in physics, as Jose mentioned, from Rutgers, and a PhD in space physics from UCLA. And I've been this, if you just do the math, for about 30 years in NASA and the commercial space. And I worked more on the software side, on spacecraft calibration, mission planning. And these days I'm a speaker and media consultant, and I do a lot in terms of training and education. So some of the missions I've worked on are the Hubble Space Telescope, the Mars Rover program, and the Herschel Space Observatory for the European Space Agency. And I work on AstroHub, and I'm also the advisory board for the Global Entrepreneurship Network. And there's some things I do in terms of speaking. I've done TEDx, Women's Forum Asia. And then on your bottom left, what you see is probably the most difficult TV interview of my life. This was when India, where the Indian Space Agency, ISRO, was sending a lander to the moon, Chandrayaan-2, back in 2019. And I was live commentating. And if you know what happened, the lander got very close to the surface of the moon itself and then just crashed. So I was looking at the screen. I had the reporter on one screen. On the other half of the screen, I had the shot for mission control. And if you just can read data, you can look at a launch profile, which is just altitude versus time, and it just goes blam, it goes straight down. And I was just like, okay, I just know what happened. What am I going to do now? Because you don't want to say anything. So that was actually quite a challenge. But it was one of these things where doing a lot of public speaking did help. And I have to just say parenthetically that some of the labs that we did at Rutgers, it was really cool that we were allowed to speak during the labs, and I think that sort of paved the way for me to just keep going and talking in public about tech. So this is a picture from 1990, about 6 weeks before the Hubble launched. So this guy here is Riccardo Giacconi. He went on to win the Nobel Prize in astrophysics a few years after he was our director. And you can see me way back here, one of the few female brown faces in the entire sector. This was on the Johns Hopkins campus, and what we did was we did instrument calibration through software, taking out dark currents and other instrumentals in the pictures that were coming down from outer space. It was super cool because we were one of the first people on the planet in all of human history to be able to look at these objects from the distant universe. So let me talk now about new space, right? And what I want you to do is just really understand where we are today in terms of new space is analogous to where we were in the computer era back in the 80s when I was at Rutgers. So on the left here, you see this was a Sun workstation. This thing cost $54,500 in today's dollars. And these were newfangled, expensive, and they were so hard to come by that on the Hubble, I worked in a computer room that had a numerical keypad, a lock on it, so that people couldn't actually get in there. And this thing was rather large, would take up, a good part of a desktop. It was very deep, very large. And it had 150 times less memory, 150 times slower, 200 times less memory, and was 100 times heavier than the cell phones we have today. So what we did is we went from these computers here to miniaturization of technology in terms of these big brick phones that people used to have. This thing was literally the size of a brick. And then you go to these cell phones you have today, which can cost you $800 or less. And the computer in your phone today has so much more capacity power than the big computers that we had back in the 90s. So that leads to space technology. And what I'm showing you here on your right side is what's known as a cube satellite. This is an industry standard. These things are 10 by 10 by 10 centimeters, and you put solar panels on the outside, and they really do fly in outer space. And many of these have the same capacity as satellites from 20 years ago that would have cost you hundreds of millions of dollars. So this is a desktop model that we use in our courses. That's why I'm just holding it. I'm not in a clean room. There's a camera on board. And one of the things that we do in our training programs is lead you through a simulated mission development and operations program where you use this particular camera on this satellite to do a selfie. So when we talk about disruptive innovation, there's, all of a sudden there are new sectors that come along and new jobs. A good analogy for that is horses. Now, for most of human history, we used horses and carriages to get around from, one place to another. There were entire industries built on the breeding, the care, and the feeding of horses and of building carriages. And then all of a sudden, what happened? Henry Ford developed the Model T. Now, when the Model T first came out, it was not widely accepted, other than the fact that it was expensive and unreliable. It scared horses. So people would go by, and if an engine would backfire, sometimes these horses would get terrified and just go on a run, and they really posed a public danger. So adoption of this new technology was just kind of slow in coming, but then when it did come, it took over. Like, none of us could actually imagine taking a horse and carriage anywhere now, right? And so the distance between service stations for cars versus for horses and carriages is very different now. And we have fueling stations, and the world is moving in a whole different realm in terms of technology. And of course, the Tesla, my favorite car, is one of our later technologies that is taking over. You may have heard recently that GM said they're going to move to an all-electric fleet in the coming decade. So this has also led to some really interesting opportunities in space. We've got the SpaceX Falcon 9, which goes up, and it's going up like every 2 weeks now with different kinds of payloads to space. I don't know if you saw the Super Bowl yesterday, but they're talking about space tourism and sending up. There's a contest. You should look it up and just go and enter if you actually do want to go to space. It's an amazing opportunity. So the democratization of space is happening very quickly. And there are a lot of things being done right now on the International Space Station. So the ISS is actually a satellite that orbits the Earth with people living on it. We've had people living in outer space for 20 years now, 24/7. There's always a group of astronauts up there between 3 and 6. And they do research and R&D in all kinds of sectors. I'll get into that in a little bit. But one of the things that we do is we have student experiments that we run on the ISS. So it's the real deal. Students run experiments in space. So this is one of our CubeSats. And what we really want to do is democratize space technology and services, because the global ecosystem now has changed. We're moving from a proof of technology sector to a sector that's defined by consumer-related goods and services, right? So it's no longer just, hey, let's fly it, isn't it cool, it can fly? It's what can we do to help your average consumer down here on planet Earth with space technology? And we're helping with that ecosystem development through hands-on training with CubeSats, astropreneurship, and ISS research. And we're primarily targeting professionals and university students from all disciplines. So here's your third poll question. How much does it cost to build and launch a handheld CubeSat? So again, this is a 10 by 10 by 10 centimeter industry standard. It's built with off-the-shelf parts. And depending on what you can do, you can put a very basic sensor in there and you can launch it for about $300,000. That's answer A1. And that's about the cost of a expensive Ferrari, right? I mean, it's certainly not something anybody has in their back pocket, but it's really just become a much more accessible price point for universities and for other organizations because of the miniaturization of electronics and the standardization of parts has made it such a difference in terms of the rapid growth of the sector. So this is one of my favorite images of Earth. You actually see it here in my background. This is the SpaceX Dragon capsule. Here you can see the streak of light. It's burning through the Earth's atmosphere. An astronaut looked out the window of the space station after releasing this using the, whoops, let me go back to that for a second, using the Canada Space Arm. And so what you see here is the Earth's atmosphere. That's that beautiful strip. And then you can see stars in the background. So this is actually just an example of the kinds of things that we can now do for students in outer space. All right, so let's just say you want to get into the space sector. You have a couple choices right now, right? One is you can go and Google, and that's pretty hit and miss. Maybe you'll get some decent resources, maybe you won't get much. The other option you have today is to sign up for a university degree program, which some of you have done in engineering, but not everybody can do that. And even in the engineering world, there are not necessarily courses that are immediately relevant. So what I did, and which you would have to do in any job to some degree, is you just learn as you go along. But if we're talking about rapid growth, and if we're talking about the sector growing quickly, you can't just have everybody going and getting an engineering degree when it's not relevant or appropriate, and it just is a big commitment anyway. So what we do is we offer that hands-on CubeSat workshop that I just was telling you about. Here we are, this is our CETO Leeway, and this was a course we taught in Australia, where this laptop here is hooked up to this CubeSat, and in the end, I was mentioning to you that there's a camera on board that you can use to take a bunch of selfies. And this is what it ends up looking like. This particular image of all the people with their smiling faces and the mission parameters is what comes up on the screen, which we call mission control, and everybody's networked together. It's actually pretty fun. So let's talk about how space benefits you right now. I think many of you might already know that your phone talks to outer space hundreds, if not thousands of times a day, right? How does your phone get its location services? What it does is it uses GPS satellite signal to triangulate where you are. So sometimes when you bring up an app, you can see that where your location is shifts a little bit. That's because your phone is actually accessing multiple signals from multiple satellites to try and figure out where you really are. And it's not just things like the phone that you're holding in your hand right now. One of the most interesting benefits that I can come up with is this is a Mylar blanket. We all know what Mylar is. It's a very lightweight insulator, and this is the Herschel Space Observatory that I worked on. The Mylar's this yellowish gold stuff. Somebody who doesn't work in the space sector realized that this material had really important implications, and there was a really interesting way in which people could be helped because it's so good at thermal control. It can be used to keep people warm. So you can go on Amazon right now and order one of these for less than like $2. And the people often use them for camping, and you can use them for travel. And they've also been used by marathon runners. So when you finish a run, so that you don't get chilled, you're giving these blankets. And another use case that I think is very important is these are being handed out on a regular basis at refugee camps. They're lightweight and durable, and they pack up super tiny, right? It's like smaller than a piece of folded paper. So these are being distributed to people on an emergency basis as well. Another really interesting use case for space is the development of pharmaceuticals. Microgravity provides a really interesting environment to manufacture pharmaceuticals. You are outside of the pull of Earth's gravity. So there are a lot of these synthetic medications that can be modeled on the computer, but they're large, and the tug of Earth's gravity makes it very difficult to manufacture them, but you can put them, can somebody mute please? Thanks. But if you go into outer space, you can make these very tenuous base structures and build upon them to develop new kinds of pharmaceuticals. So the drug that you see on your right is called Prolia. It's an anti-osteoporosis drug that was tested on mice on the International Space Station. They sent up a group of mice who were injected with the drug and a group that were not. And as you might know, when you're floating around in outer space, there's no loading on your skeletal system. So bone loss is super rapid. So what they were able to do was let the bone loss set in very quickly on these mice and compare the two groups to see whether the drug worked. And in fact, it did. And these guys are doing some crazy thing like $750 billion worth of sales per year. So for them, from a strictly commercial standpoint, being able to accelerate their clinical trials by even 3 months is going to make a big difference, like hundreds of millions of dollars. So that's one application. And then Earth, as we said earlier, has a unique vantage point. You can observe large swaths of the Earth from above. And we are now observing every point on the Earth every day, every point on the Earth every day. So it's not that you have to wait for days and days to understand whether there's a storm coming at you or where there's a forest fire that has been lit in your area. You can get these data immediately. And we talked about post-COVID global economy. One of the issues that we face actually as a planet now is food insecurity. I'm sure many of us last year went through a phase initially where you just couldn't get certain things at the grocery store. And that wasn't because of the food not being produced. It was actually a supply chain issue. And you can take images from space of transportation routes and also of where the agricultural yields actually will go in the longer run. And that helps you quite effectively to figure out how to handle these supply chain issues. And finally, this is one of my most favorite topics is asteroid mining. You can, in the longer term, think about, I'd say in the next 5 to 10 years, going off to asteroids and getting minerals from them rather than from here on Earth. So if you know what asteroids are, the majority of them are between Mars and Jupiter, and they're a planet that never coalesced. So they are basically made up of the same material that the Earth is. But the difference there is because there is no gravity, the material that sort of came together to become these individual rocks, these asteroids, is still differentiated. So it hasn't been churned by millions of years of geological processing. So extraction is much more straightforward. Here on the Earth, you have to use chemicals to leach out various constituents to be able to get at your material that you really want to mine, and that contaminates groundwater. It's very unhealthy for the miners. But if you were to send a robotic mission to space to get whatever you need, all the rare metals like molybdenum or whatever it is that they need these days, you could actually do that pretty easily on an asteroid without hurting planet Earth. And this is part of the vision of some of these billionaire entrepreneurs, part of the reason they want to move off planet. So, okay, so back to you guys, young people at Rutgers. I'm thinking about what a unique time this is in history right now. Our generation is leaving you with some difficult circumstances. Right now we have COVID, and that has led to global food insecurity. But it's also a situation where those of you who are graduating are going into an economy where there are not a lot of jobs, and you'll be competing with students from last year who understandably don't have jobs yet. I have a daughter who's a senior in college, and she's in this situation. And not only have we given you that, we've also given you this situation with climate change. These are some of these monster storms that are coming up. I don't know if you heard yesterday, there was a glacier that collapsed and there was massive flooding in northern India, and they're still looking for survivors. My older daughter's doing a PhD studying glaciers, so she can speak to this. These glaciers get these big melt points now. The top becomes liquefied and then they just break open and then the water just gushes forth. So, between the pandemic and the situation we have with climate change, you guys face a lot of challenges in the coming years. But what I think is really true is when you're in your 20s, you still are very much what I like to call a nonlinear thinker, and you're thinking outside the box. This is a great opportunity for all of humanity to take your talents, your diversity, and your different kind of thinking and bring it on board so that we can solve some of these problems together. And of course, everybody talks about diversity these days. And I think what's really key for that is it gets people with different kinds of thinking to come on board. So I see the current situation, here we are in February 2021, of a time of crisis, but also a time of opportunity where we can get you to come on board and figure out solutions for fixing the world in a way that perhaps a middle-aged person could not. if we look forward a little less than 20 years, there's a report that was put out by Morgan Stanley a few years ago. I've got the link on the bottom. Email me if you want it. If you can't, just copy it down now. The space economy on a global scale will be worth about $3 trillion. It was worth around $350 million, I want to say, back in 2016. So it's growing very quickly. And as we mentioned earlier, we're going from a proof of technology sector to one that is driven by consumer products and services. So where's the workforce for this? How are we going to be able to support a $3 trillion economy if we don't have a workforce that's actually in place? And the solution here is training and education. So here's an example of something that I was actually trying to do recently. Space Talent is a website that lists space-related jobs. So I need somebody to do digital marketing. We have workshops all the time, and I need somebody who's really good at putting together the messages and just getting the advertisement out there. So I decided I would go into these 9,385 listed jobs and look for somebody who does digital marketing, right? So you can see in the search engine, I put in digital marketing, 9,385 available jobs. And this is a big name in the sector. These guys have a lot of jobs posted. But what happens? We're sorry, there are no job openings with this criteria. So if I'm trying to build a circuit, maybe I can find somebody. But if I'm trying to build an ecosystem, a business that has people with different kinds of expertise that can come on board, there's really very limited opportunities for bringing people on board. So as the sector grows, we're going to come up with more and more solutions from outer space. We talked about food security. That's your second panel here. And with regard to food security, you can not only figure out supply chains, but these days people do something called hyperspectral imaging. That is taking images in multiple wavelengths and putting it all together with information on soil chemistry from the ground. And you can actually figure out when a crop is likely to mature. So that helps the farmer get ready to send the crops to market. Now, in earlier times, what people would do is just use averages of weather models and say, my ancestors picked this crop at such and such a time. I'll probably be able to do it around that same time, plus or minus a little. But with climate change, all bets are off. So we need to come up with new ways to actually understand what's going on. So you can use images from space of agricultural lands to understand crop maturation, crop disease. And you can also use this in terms of commodities markets to predict yields much better than the spreadsheets that they used to use earlier. So food security is one. Space-based internet. This is a depiction of Elon Musk's Starlink cluster, which I'm sure you've heard a lot about. They send up many of these. There are a few hundred of them up there already. But these little points here represent nodes where they're able to contact every point on the Earth with internet every day. So this is Saharan remote Africa, which they plan to provide full connectivity to. So imagine the implications of that down the road. Right now with COVID, we have some serious issues with people in less urban areas who have difficulty accessing internet. So they've already done a test in Washington State with a Native American reservation where they've been able to increase the internet access speed by about 1,000 for these people. And it's been a game changer for the kids in the schools there. We also talked about climate challenges. So if you have these fires, like we lived in Southeast Asia for a while, and one of the problems they have over there is these palm oil plantations get clear cut and burned down, and the smoke is terrible and it lingers forever. Now, since we're able to image the planet every day, imagine having an infrared sensor and finding out that there's a fire burning in your area now versus waiting 2 or 3 days. And so imaging every day, and because these CubeSats I was telling you about are so affordable, you can now take your own satellites, launch them, and have them look where you want, when you want. And this is particularly important for countries with smaller economies, so they're not reliant on the bigger countries for data handouts if and when those become available. And another interesting application that I want to point out to you is urban development. There are issues with encroachment in various places all over the world, particularly when it comes to indigenous lands. And I think this is an example from New Zealand. from the company Planet. So there was an area where the local indigenous community thought that it was their land that was being built upon, and they couldn't really get in there to figure it out. So they got satellite imagery and matched it up with actual maps and were able to determine that the development was happening where it shouldn't have been. And this is something that couldn't have been done without space-related data. So let me just take a break here and ask you to think about which space-related application in this poll here you'd be most interested in working in. And I've just provided these 4 examples here just to get your thought process going, right? There are a lot more opportunities than this, but just think about which of these you currently have skills for that you could work in. So for example, if you are working in urban development, you don't have to necessarily have an engineering degree. If you understand something about how government policy works, or if you understand how social structures work, you could go in and you could figure out how to help use space data here. For food security. If you understand how cultures work, you could figure out how to get sustenance farmers to go actually pay to have space-related agricultural data on their phones. Somebody has to convince them that this is a product that's worth using, and that would usually have to be somebody who's not directly working on the technology itself. So there are lots of opportunities here. So if you want to look at business and marketing, media communications, legal, or finance as areas where you have an interest or expertise, there are a number of things that I can immediately think of where you could contribute to the sector. Sector growth and customer acquisition if you're doing business and marketing, consumer buy-in and tapping natural inspiration. And I think this is super important because the public is getting more and more excited about space. We just need to be able to tell them the story even better. The legal side of space is a big, big deal. The UN does have cooperative treaties, but who owns outer space? I told you about the asteroids that can be mined. Who owns those? If you send a spacecraft as a private company or as a nation to one side of an asteroid to pick up some very valuable minerals, what if somebody else goes to the other side of the asteroid? How is that going to be resolved, right? So these are all things, we have to have enforceable policies and treaties, and nobody has really worked that out yet. And then, of course, the finance sector is important because, as startups, everybody needs financing. If you want to talk more along the sciencey kinds of areas, medicine, biological sciences, social sciences, engineering, not space related, or engineering in the space sector, we talked about pharmaceuticals. We haven't really mentioned this, but space tourism is an up and coming area. That contest that you may have seen on the commercial on the Super Bowl yesterday, they're opening it up to anybody who wants to apply, but somebody's going to have to decide what kind of medical protocol to put in place. Because if you take a middle-aged person who's on high blood pressure medicine, for instance, and you send them into outer space, what happens to them? Are they going to be okay? Because the last thing you want as a space tourism company is for somebody to have a crisis when they're up there. And then that leads to the whole thing of how do you handle medical situations in space. We're talking about going to the moon in the coming decade. We're talking about going to Mars. Those are long trips, and you can't send along, an operating room with every single mission. You have to be able to figure out locally what to do and figure out exactly who can go so that you can avoid as many emergencies as you can. Because remember, astronauts are they're in perfect shape, but not all of us are astronauts. So in the social services, you can think about applying space tech for the greater good. This is like the Mylar blankets I was telling you about. And then in engineering and science, of course, we can talk about tech transfer and new applications for technology that already exists. And if you are a professional space worker, then you can continue to push the boundaries. So just in the context of all this, let me show you this. There's a nice website called spacehub.co. And this lists their, I just did a download of the startups that they have listed in this database. And in 8 months, the number of startups went up by about 140. And this is during the pandemic. This is when we're having a serious economic crisis worldwide. And you can see the cluster is majority in Europe and then in North America. Our offices are here in California and also in Singapore. And people are working on everything from 3D printing in space, additive manufacturing, to blockchain, to launch. There's a lot of competition to Elon in terms of launch vehicles. There's a company called Relativity that's doing 3D printing of an entire rocket, and that has serious implications for industry as a whole. Medicine, we talked about the company, the pharmaceuticals in Amgen, space tourism and weather, and there are lots and lots more areas where people are thinking about applying space technology to meet the needs of people here on Earth. So what's happening during COVID-19? I'm sort of coming to the end of the talk here. So what I want to do is give you a couple thoughts. One is we do these online workshops, right? And so we have one coming up in mid-March on space data and machine learning. And because you guys are Rutgers, if you can just go ahead and send us an email at info@astrohub.co from your rutgers.edu email address, we'll send you a free discount code. Cost 20 bucks, but I know as students that 20 bucks matters, right? So go ahead and send us an email and we'll give you a discount code if you want to attend. We have 2 separate times for the same workshop being run twice because we are global and we have to be able to address time zones. UTC, that's universal time. You can just go look it up and see which of those times works for you. I'm in California at the moment. I've been stuck here with COVID. So these times are both times when in California a reasonable person would be awake. So, but anyway, pick whichever one works for you and send me an email if you're interested. And then, okay, the future. Let's think about the future. What I really want to look at is in terms of where we can all come together and make a difference. And it would be really cool if Rutgers or some other institution set up a center for space excellence. Because one of the things we find, we advise universities worldwide about setting up space programs. And one of the things we find is administrators are reluctant to spend money on facilities that will not be used a lot. And particularly when you send up a payload to space, you have to go through what is colloquially known in the sector as a, you have to take your payload and you have to put it into a thermal vacuum chamber and cycle the temperatures, because in space, you know, when you're facing the sun, it's very hot. When you're not facing the sun, it's very cold. And those thermal blankets, the Mylar we talked about, are not enough. So you have to be able to temperature cycle your entire system. And the other thing that your payload has to survive a rocket ride, right? It's pretty shaky going up. Space is very still, but on the way up, there's a lot of shaking. So you have to have these shaker tables that you put any components you build in to make sure that they don't fly apart. And that's an issue not just for you, but for everybody else you're sharing the rocket ride with, because you don't want to have your system fall apart and then have, you know, fragments going and hitting everybody else. So these are very important tests, but they only occur at a certain stage of the life cycle of any spacecraft. So institutions are reluctant to build something that's not going to be used that often. But if you are a center of excellence, you can come together as a group and have a shared facility where the facilities are going to be used more frequently. And most importantly, what you do is you create an environment for like-minded astropreneurs, right? You know, as they say, the most important asset to any company is the people. And if you have a bunch of like-minded astropreneurs coming together, sharing ideas, I think you make a lot of progress, and you end up basically with what I would call a nucleation site for space workforce development. So I'll just kind of leave you with that. And then here's my final poll question. What fields of education provide the skills needed to work on space-related products and services? Engineering and science, media comm, law, econ, social sciences, biological sciences and medicine, business and marketing, or all of the above? And I think by now you know the answer, right? So takeaways for today are space technology and services help the citizens of planet Earth, and access to outer space is becoming democratized on a global scale, and the global space will develop exponentially. And I hope I've done my job correctly in the past half an hour or so, and that you do believe that rocket science is not mysterious and that it is not inaccessible. And finally, that I do want you to believe that there is space for everyone in this sector. And that's kind of it. So thank you for your time. I know that some of you have questions. I'm happy to answer them. So I will turn it over at this point to Hossein to be able to pose those questions. And I'm happy to address anything anybody wants to ask.
Hi.
So thanks.
Yeah, thanks again. Thank you so much. That was amazing. I want to remind everyone, please, if you could keep yourself muted and your video off. But if you have any questions, please put it in the chat, and I'll be monitoring this chat definitely throughout this. And Dr. Bhattacharya, if you'd like to stop sharing your screen so we could see you on the big screen, that'd be helpful as well.
All right, there we go. Okay, cool.
Okay, nice. Okay, so we do have a few questions. I'll be a little selfish and start with my question first. But one thing I wanted to ask you, I guess just in general, was you talked about disruptive technologies early on, like the Model T and propulsively landing rockets that changed the industry. What do you think is the next big thing that will change the industry? Whether it be like ion propulsion or AI or something that will change the way we I guess do space exploration and really make the industry take off.
I think you kind of got it. That's a good question. I think AI is really the way to go because we're seeing this sort of combination of AI with space tech already, and possible applications would be having sensors all over the outside of your spacecraft to understand what's really going on some of these longer journeys, particularly with humans on board. And so decision making autonomously for a spacecraft, autonomous surgeries, and then launch sequences that are controlled automatically. And a good example of AI we use in space tech is the SpaceX Dragon, the Dragon Crew 2 capsule that went and docked with ISS a few months ago, did it autonomously. It's no longer driven by hand like in the days of Neil Armstrong. That was done autonomously using AI. Yeah.
Great, thank you for that. We also have a few other questions. One from David Surback. He wanted to know, what skills do you consider to be the most valuable in this line of work? I think you kind of touched on that, where I guess it's really diverse, but expand on that a little more, I guess.
Yeah, so I would say the most important thing to remember is the most valuable resource of any organization you work with, which is the people. So every job has different requirements, but you have to be able to communicate in whatever way is appropriate. I'll give you an example. When I worked for the Spitzer Space Telescope in Southern California, I had an office mate who was just the most brilliant engineer you can imagine. He would be able to recite thermal profiles for this infrared camera that we had just sent up into space. I'd be looking at the calibration going, okay, these pixels look off, what's going on? And he would literally be able to say, well, that was July 2nd of 2003 and blah, 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 blah. But you know what? The only way you could communicate with him was by email, because he would not make eye contact, right? And I sat with him for about 1.5 years in that office, and he finally got comfortable with me. But anybody else would really need to, just send him an email. So I would say he was smart and important for the team, but it sure would have been helpful if he could actually be able to communicate with people, in a more effective way. So communication skills, I would say, are probably the most critical, just regardless of what your background is.
Thanks. Yeah, that's one thing I learned, especially helped me a lot not being shy and going up to asking questions to anybody, no matter who they were.
Yeah,
so that's
right.
a great one. We have another question from Dr. Michael Goodkind. He said space tourism is priced at about $55 million, I'm guessing, for orbital tourism. What will it take to bring the cost down to something more reasonable?
Yeah, 55 million, isn't it? That's a lot. I certainly, as Hossein mentioned, I want to take my husband to space for our 50th wedding anniversary. I don't envision having 55 million by then. I mean, we went to Bali a few thousand. I think for our 25th, for our 50th, we can probably afford something along those lines. The most expensive part of any of these space tourism projects is de-risking the potential loss of life, right? So as we continue to scale up, we start to understand more about the human body and how it forms. And as the various systems and subsystems become scalable and producible on a larger scale, the cost will automatically drop down. It's just like automobiles used to cost many, many years' salary back when they were first invented, and now most of us, everybody pretty much owns one. So it's just going to take more people going up and us understanding better how the whole thing works, and then mass production of the components, in my mind. So I think we have 20 years to do that. I think we'll get there.
Yeah, I'm hoping hopefully soon this year or next year, Virgin Galactic and Blue Origin start flying people as well regularly. So looking forward to that.
That's right.
And you had mentioned that in the future you wanted to go on your 50th anniversary to space with space tourism. I guess, what do you envision the space tourism industry in the scene to look like at that point? And I guess, what do you hope it to be cost-wise, or how regular people go into space? I guess it's good to be optimistic, but I don't know if you...
Right.
Yeah.
So I have a LinkedIn article I wrote on this a few years ago. So you can just go onto LinkedIn, look up my name, and just go look up the article. But basically, what I envision is a space ticket being about the same airfare, same as a first class airfare going somewhere internationally. So what is that, like $10,000 or $20,000? So it's not cheap, but I figure if we've been together 50 years, we can put the money into it. And I think initially the space experience will involve orbits around the Earth. So you'll go up above the surface of the Earth to where you can see that background, like, you see behind me, the strip of the Earth's atmosphere, and you'll just orbit around in microgravity for probably a few hours and then come back down. So you'll get that effect of seeing the Earth from above and flying around it, like one orbits every 90 minutes when you're in low Earth altitude. So I think that's what it's going to look like. Yeah, very pretty cool.
Great. Yeah, I'm hoping I could get to do that one day as well. We have two questions from Sarah Terracina. Her first one was she was wondering how you transitioned from being a NASA civil servant or working at NASA to starting your own business. And the second one was about, she was saying that she's currently on the Rutgers CubeSat team, and would we be able to join your workshop as a team? And what advice do you have for our team that is just starting out? They just submitted their proposal in the winter. So I guess that's
cool.
Two separate questions, but the same person.
All right. So first of all, yay, Rutgers CubeSat team. Awesome. I think that's cool. I'd love to talk to you more to learn about that. Maybe we can set up a conversation offline. So in terms of the transition, in the late 2000s, I was working on the Herschel Space Telescope, and I was starting to hear about people I knew who had started leaving JPL, that's Jet Propulsion Laboratory, one of the NASA centers, and going off in Southern California to work for some company called SpaceX. I was like, I wonder what that is. And they're like, oh, that's run by that old PayPal guy. So I went and looked it up. I was like, this is kind of cool. And I really liked his idea of doing things quickly and more affordably. And of course, we know that Falcon 9 rockets, they failed one after another initially, but I could see the vision and I was excited. So what I did was I realized where my skill sets were running short, and I was working as a scientist. So I didn't have a lot of administrative experience. I didn't know how to do budgets, and I needed to learn how to just administer stuff. And so I quit my job at NASA and started working at a university consortium where I set up a research development program from scratch. And that involved reviewing budgets and then having people submit the proposals just like the CubeSat team did, and helping people figure out their facilities and just doing all those kinds of things that you need to do as a CEO of a company. And then in 2013, I started poking around trying to figure out what I was going to do. We had an opportunity to move to Singapore, and I realized that in Singapore, everything works, right? It's very efficient. Companies are well run. There are clearly tax advantages. And they had a very nascent space economy there. They had a university at that point that had launched some CubeSats, but that was kind of it. So that represented an opportunity, right? So because when you're in first, and as an entrepreneur, you'll know the term first mover advantage. You can kind of define the direction that a sector goes and just start doing your thing, and everybody else will follow. So then I set up the business in Singapore in 2015, and I started giving talks and talking to everybody I knew in the sector and tried to figure out where my niche would be. And I realized pretty quickly that there is a real shortage globally of space workers, right? I mean, it's very hard to find people, whether you're looking at somebody who specifically works on propulsion system or somebody who works more, generally on business development and marketing. Very hard to find those people. So somebody needs to get all those qualified people who have the right skills to start looking at space as an actual point of entry for them, possibly in their careers. So that's how I found my little niche, and we have clients all over the world now. COVID has been a challenge for us like everybody else, but we still are able to send. We have only one experiment going up to the space station this year. It'll be our 8th. It's going up, I think right now the launch date might be in June. It's CRS 20, Space 20, I think 22, CRS, SpaceX 22, the resupply mission there. So that's how I got to where I am now. It's actually really fun. It's really fun. Yeah.
Yeah, no, it sounds great. And it's great you're doing this, because I think that's something I struggle with as well too. When you tell someone you want to work in aerospace or work in space, they kind of scratch their head and they're like, you're not a rocket scientist. I'm not a rocket scientist. I don't know if I could do that. So I think people need to realize there's a lot more skills there. There's another question from Matthew Fermato. He said, do you think space medicine will be a subset of a corporation like SpaceX or something, or a separate entity once space travel becomes cheaper or more available? And this kind of, I'm going to add my own question onto this because this is related to something I was thinking about, where, what do you see as NASA's role in the future in conjunction with the commercial space industry, as a lot of these companies are taking hands off, like taking, work like launch off from NASA's hands, but NASA is obviously still doing a lot of space medicine research, I guess. Do you see this as something that it's something corporation would do, or like the government?
Well, I would say to Matt, this is an opportunity for you, really, because there's nobody out there meeting what will soon be a very significant demand in terms of understanding what goes on with the human body. So we've had 500 some astronauts in space so far from around the world. They basically serve it as biology labs, right? They're constantly having their heart monitored, their blood checked, oxygen, everything about them is constantly monitored. So there's a wealth of data out there. Nobody has bothered to put it together to date. If I wanted to just know, when does the hemoglobin level fall off very quickly for somebody in outer space? People know this, but it hasn't been documented across gender and race across the world. So the data's out there, and it's out there, I'm going to say to some degree in the aggregate in the public domain, because it's governments. Somebody needs to have a company that goes in and develops a space protocol so that you can put together, here's what would be safe in outer space. Here are the kinds of medicines somebody could take or should not take. And then your company becomes the go-to. So like Richard Branson wants to send people up. He's now got a team of physicians that work for him. And because they're talking about the first time going into space, they're doing this. A lot of people are going to be coming on board, and then your company could be the go-to in terms of this very valuable resource because you've bothered to put together all this information and fill that gap, fill that need that nobody else has done. So governments can only do so much. I think governments are very good at spending billions of dollars on big projects, and they should be left to do that to sort of push the boundaries of R&D. But I think on the commercial side, space tourism being something that serves, an emotional need for the well-being of people, I think that's something that the commercial side should definitely just jump on. So yeah, I'm going to see a startup from you, Matt.
Yeah, definitely. Yeah, thank you. And I guess to add on to that as well, I did just notice yesterday that SpaceX posted 2 job postings, one for flight surgeon and one for space medicine researcher. So it's already happening.
It's already happening.
It's only going to grow a lot more as well. We have a question from Gabriel Franco, who's asking, what are the potential environmental pollution risks involved with making something like going to space commercial? I guess making it a lot more frequent as well. Air travel has already been shown to have a rather large impact towards greenhouse gas emissions. I would imagine it may take considerably more emissions to reach space consistently.
I think that's right. There are companies working on green fuel, right? And so we'll see where they end up going. There's a certain amount of thrust you need, a certain amount of ISP just to break out of the Earth's gravity, right, to get to a certain spot. But you can do a number of things. One is you can look at fuels that burn more cleanly. And the other is you can get yourself into space and have some kind of a space station, a way station from which you can launch further. There's no reason we have to stick to this current model of going from the surface of the Earth to outer space. You could do this in various steps and combine that with 3D printing using local resources on the moon, for example, to build your next spacecraft. It doesn't all have to be done here on Earth. So I would say maybe those are 2 areas that you can look at.
Okay, thank you. Now I'm looking for a couple more questions here. I guess one question I have for you, we only have time for I guess 1 or 2 more, but what do you see as the greatest hurdle, I guess, keeping the commercial space industry from being completely self-sustaining and not dependent on government contract in the future? I know the whole business model for commercial space companies is to be commercial and not depend on the government, but I mean, they've obviously, early on, a lot of them depend on those contracts to get started.
Yeah, I think that's definitely true, but it is precarious because every administration that comes in has different priorities. And, I suffered personally from this a number of times where I was about to start work on a certain project and Congress canceled it. We had a new administration. And so relying on government is important, but it's a bit unreliable. What I think really needs to happen is finance companies. So venture capitalists, angel investors, financiers need to think of space in a completely different way. So when you invest in a company, you're coming in, you want to make money, eventually you get profits and you share the profits, whatever. They don't like to do that in space because there's an overinflated sense of risk. You know, I mean, when was the last time that a rocket blew up that had payloads on it? It's been a long time. It's fairly reliable, but people still think of it as very risky. They think of it as expensive. As we've all discussed, it's a lot less expensive now. And they think it takes too long, and some technologies do, some don't. But look, they're willing to invest in med tech. And some medical devices have to go through like a 10-year approval process with the FDA before they're put out. Investors are willing to invest in those. And we need them to expand their vision to include space technology as well. So just to get back to your question, I don't think it's just relying on the government. I think we need to get the finance people to look at space in a more realistically, more consistently with what it is, and just walk away from their preconceived notions. And then I think the sector will continue to grow. I think that's the way it has to be.
Yeah, a lot of these problems, a lot of engineers are only good at technical problems, but a lot of these problems are bigger than technical and political and stuff. Yeah. So that's why it's important to have a lot of policy people in there as well. I guess for my last question, I was going to ask you, this might be a bit of a long question, but this is something that needs to be addressed because you had talked about mining, asteroid mining, and democratizing space and whatnot, and you know, space law right now is kind of ambiguous because it's not really that common. And like the International Space Treaty and other things in the Artemis Accords, we have laws that I guess can't really be enforced. So I was wondering, what do you think needs to be changed in space policy for the future to actually democratize space when it becomes really common, to ensure in harmony in space between people, and who would be the person to enforce that, or you know, entity to enforce that, you think?
Yeah, that's really an important question, and that's one of those things where if we don't figure it out, it really could limit sector growth. You don't want to have international incidents happening over, you know, whatever we're doing in outer space. I'm not a space lawyer, so this is not my area of expertise. But what I would suggest is, based on my understanding, is we can look at Antarctica as a model. Nobody owns Antarctica. We have a global agreement to use it as a research station and to work cooperatively there. So that's a starting point. In terms of enforcement of agreements, the problem we have is space is really, really big. So you can go out and, you know, I mean, there are hundreds of thousands of asteroids. How are you going to enforce it? I don't know the answer. But the world would have to come together and come up with some kind of mechanism to, you know, provide consequences for behavior that goes against agreements. And to date, people haven't, you know, they've been following the rules in Antarctica, but I think that's because it's hard to get to, and we haven't found anything there that immediately can be commercializable. But I do think that, you know, we're already digging around on Mars. We already know how to scoop up stuff. We've had asteroid return missions now a couple times. And we have various kinds of technology that can be put together to get to asteroids. So it's just a matter of time before robotic missions go out there. So I agree that it has to be figured out. And I would just say maybe think of Antarctica as a template.
Yeah, thank you. And that's a perfect example of why we need more space lawyers and space policy people.
Because we need more lawyers, guys.
Yeah. So at 6 o'clock, that's all the time we have, but thank you so much to everyone that attended, and thank you, Dr. Bhattacharya, for coming as well. It was great talking to you. I learned a lot in the past hour talking to you. Just remind everyone, the recording will be posted shortly, and if you want to share it with your friends or colleagues when it's posted on the Rutgers Engineering website, feel free to. And please come to more events like this because they're really informative, and I definitely will be coming to more of these.
Yeah, me too. All right. Go Scarlet Knights.
Thank you. Have a good day.
You too.